Hey, it's Rich here. I'm doing a little follow-up here with some of my recent blogs with convenient gap, the concept of convenient gaps. So we've talked about already in the podcast with my one client, Chaz, how the convenient gaps in the drawings allowed the contractors to have some flexibility in the field, and talked a little bit about that with material tolerances and that with the blog. Now I'm going to just show you a quick example of how that's done in the drawings themselves. So I'm just going to draw a very simple plan real quick. Basically, let's just draw a box. So just say we have just a simple square for a building. Actually, I'm going to double the lines up here because I'm going to show you in a second. Let's say we have a door here, and let's say a window here, two windows, maybe two windows here, and then another window over here. So just get a little bit more fine detail where we have kind of the window jambs. Just do this real quick. These places. And then let's do a door. We'll do a door this way. Draw up a door. Go like that. So we have all of the base plan here for whatever this building is. Let's call it like a little studio or something. So now what I'm going to do, I'm just going to this is kind of showing a little bit of a drawing thing too. Sometimes how we might draw by hand to show some layers of information. So here is where the convenient gaps come into play. So if I'm going to add some dimensions to this, typically something like this, I'll have a dimension here for, an overall. So let's just say this is 20 feet. So we'll put 20 feet, and this is also 20 feet in the other direction. And we'll say 20 feet. Like that. Okay. Make sure I don't let the ink run. Okay, so that's one layer thing, or one level of dimension. So we have 20 feet in both directions. Now we want to dimension the windows and the door openings. We can do it one of two ways. Usually the dimensions are done either by the center of the opening or by the ends. So I'm going to do two examples of that. So on this top part here, let's just say we're going to dimension to the center line of this window. So go here, in here, and we're just going to assume that this is 10 feet and 10 feet. Okay. But then another way to do it, and we'll do it over here on this side, is you go to the openings of the window. Just draw a line here, and we'll add to the openings. And let's just say this is I'm going to give some masonry dimensions, and that's usually in increments of 8. So it'd be 8 inches, 16 inches, etc. So in feet and inches, we'd have 8 inches, 1 foot for 2 feet. 1 foot for 2 feet, 2 foot 8, 3 foot 4, 4 feet, 4 feet 8, etc. So let's just say this is 3 foot 4. And then let's do the quick math here. We'll say 3 foot 4 over here. Say good even 4 feet here, which then means that this is what, 6 foot 8, 10 foot 8. So divided by 2, what is that? 9 foot 4. Kind of did a bad thing here. So let's just make this easy. 4 foot and 4 feet, and then split these up into, so that's, let's say 4 foot 0, 4 foot 0, and then we have 12 here. So it actually ends up being 4 feet, 4 foot wide windows. There we go. Nice and easy, right? Okay, so that's how. So then what you have here is actually a closed string of dimensions. Closed string of dimensions. You have 20 feet, 10, 10, 20 feet, 4, 4, 4, 4, and 4. Now, down here, what we'll do, again, we know that this is 20 feet wide, so we won't worry about that. But let's just say we're going to the again, we'll do the door as the center line. So we'll do a centerline dimension and go across here. Again, this is a center line. The other thing, little dimension note that I like to do in my drawings is when you dimension to an edge, you use a tick mark, like a little slash. But when you dimension to the center lines, it's always a dot. So it's easy to differentiate that. An example like here, it's very clear that it's like that. But in other cases, it's a little, sorry about that, phone went off. In some other cases, you may have a center line dimension, or for example, like a structural dimension may be somewhere, and it might be near the edge somewhere. So it's easy to differentiate between having a dot or a tick mark that's on a dot on the center line or a tick mark on the end. So back to here with a door. Now, let's say that it's critical that the center line of this door is, well, let's go from here to be a bigger dimension. It's kind of a little easier to understand. Let's say that this needs to be, let's say 15 feet from this corner. Now, what you can do here let's just say this isn't as critical. So you can do one of the things. You could say, you could actually say 5 feet, add 5. Let's just add 5 feet. But you could do one thing, like you could say, if this is a critical, you could say hold dimension, or some other type of note that says that this is critical. Or another way to do it is say 15 feet and then have 5 foot 0, but then put a plus or minus. So what that's telling the contractor is that this can be a variable, but you need to have this 15 feet as a critical dimension. So again, using the windows in that same example, and again, we'll do edge to edge here. Again, we're going to run a line. Again, we know. Let's just say again that these are 4 feet. The windows are 4 feet, and that the ends also are critical to be 4 feet. And then in this case, maybe it's not as critical in the middle. So we know again this is 4 feet, but we can add a plus or minus dimension to the middle here. So the edges are always going to be held. The window size is going to be the window size. But then this variable for the contractor to work with, if there are any issues, could be this 4 foot dimension here. So again, if it's all held and true, I mean, this is a very simple example, but when you have a more complicated building, you're going to have situations where you may have the need for this. A great example I can give you is there was a building I saw I was taking the train into Philadelphia yesterday, and there was a building that had 2 wings. It was like an apartment or condo building, and the 2 wings were at this kind of strange angle to each other. It wasn't a 90-degree angle. So for example, here, I'll just draw it here, is it had a wing like this, and then I think there was a wing, it kind of like came in like this. So, and I'm not sure if it squared off or what, but there's this weird, right here, you can see there's a weird connection there with an inside point. So here, I could see, if I was presented with this building, is like, let's just say, even, this is an overall dimension example, I would give, let's say this is 50 feet, 100 feet, 50 feet, but then, and there may be some other dimensions throughout here too that kind of tie everything together, but then this dimension right here ends up being a variable. So you could say verify in field, or you could give it a number and say verified in field, or do like a plus minus type example as well. So that's actually a real quick example of like how you can really use it in the field. So the contractor isn't completely like isn't set on this, and what ends up happening in a scenario like that, or if there is something in the corner that's not working out correctly, they're going to come back to you with a question of like, well, which one should we go by? So this way with these variable dimensions, there's less questions coming back to the architect, or then the contractor is waiting for the architect to respond. So it kind of simplifies the process of construction there by using these quote unquote convenient gaps. So hopefully that's helpful. And yeah, if you know got any question or anything, please comment on the video below. Also check out my podcast, Rich the Architect, right here. You know, where we're talking about things like this in that podcast. So hope everything's well with everyone. Have a good day. We'll talk to you soon. See ya.